Let's now solve the second problem. Let's go over the specification of the problem first, and then you can try it yourself before you see me going over the solution. So the problem is, given a 2D array of integers, we want to return, so two methods. The first method is going to return the overall average, and the second one is going to return row averages. So we can say this is going to be an array where every element corresponds to the average of a particular row. For example, let's say for the first one here, what does it really mean for overall average? So that simply means given this particular input, you're going to return the average of all the elements in the array. In this case, we can use the same two-dimensional array from the previous problem. So it's going to be 6.5. And if you try this array over here, the overall average for all the elements over here is going to be 4.5. Okay, so the first one should be rather easy, rather simple. It's just like warm up for the second one. The second one is going to be of return type an array of integers, and the size of the array really depends on how many rows you have. So you can actually return the row averages. For example, if the input is like in a two-dimensional array like this, so that means the output array is going to be of size 1, 2, and 3. Three elements. The first element is going to be the average of the first row, and the second element is going to be the average for the second row, and also the third row, and etc. Right? So these are the expected value, which I have already calculated prior to the video. All right, so that's kind of the problem we want to solve. Let's see how we can solve it. Okay, so it's the main lesson for you to see is to see how we can calculate some global measure of all the elements versus local measures of the rows. So that's really the main learning outcome for this problem here. Let's now program one by one. Let's now first of all declare the method header, and then we'll write a JUnit test to specify what to be achieved, and then we'll code it up exactly how to achieve it, how to pass the test case. Let me first of all go to utilities over here, and then let me maximize it. So let me just follow from here, okay, and let me just go all the way to the center. Okay, the first one. So we can say public, and then static utility method, integer. Let's say get average. So this will be to get the average for the input two-dimensional array, all the elements. So integer two-dimensional array of integers. Let's say a over here, and let me just return some default value. I can say return -1. Just like that. And the second one is going to return an array corresponding to how many rows you have and calculate the average for each row. So it's going to be public and then static integer array, right? Depending on how many rows you actually have. And get average over here. And then, okay, the two-dimensional array and a. And then we can say return null. Just for now, right? Remember, integer array return type is a reference type, so the default value will just be the default value for reference type, which is null address. Okay, I should really rename it, shouldn't I? So here, let's say get row averages. Okay, it's as informative as we can. So these are the two methods we like to do, and let's now write the JUnit test one by one. Let me go back to the test utilities.java. Okay, let me maximize it. So now it would be, let's say, test. Add test. Void test number 3. Okay, and we are simply using the same array. So we can simply just copy over here. We can simply copy the input over here. So this will be the input array. And then we want to say the output is going to be an integer, actually a double. We want to calculate average with precision. So let's say double, and then output 1 is going to be, oh, you know what? Let me go back to utilities over here. So I think I should really put double over here, right? Integer is without the precision, but we do want precision whenever we calculate average. So I actually over here, I should say double over here. So input is going to be integer. However, the output average is going to be with a precision, floating point number. Let me go back here. And then output 1 is going to be utilities dot, let's say get average, and then input 1. And then what should be the expected output? So we can say double expected 1, right? Or you can put it in line inside a assert equals. That's fine too. But let me just split them. So the first one here, as I calculated previously, it should be 6.5. And then we can say assert equals over here. And then I can say expected 1 and also output 1. Just the same structure as problem number 1. And of course, since we are comparing double, so we should really allow some tolerances, right? So I can say 0.01. That's enough, right? And we can do something very similar for input number 2, the triangular array. So let me just copy just the input over here. Okay. And then we're going to do it over here. So input 2. And then I'm also going to copy these 3 lines over here. Let's rename them accordingly. So that'll be output number 2. And then should invoke the same method with input number 2. And expected number 2. And the value should be 4.5, which I calculated previously. Right? You can take it for granted. And then expected 2. And also output number 2 over here. And of course, if you simply launch the JUnit test, nothing will pass because we haven't coded up the method yet. Let's now do get average first. That should be the easy one to do. So this one will be rather standard because we simply just want to declare some variable outside the scope of the nested loop. So we can accumulate all the elements with that particular value. And then at the end, we can also divide that accumulated sum by the number of elements in the array. That's basically what we will do, right? Very standard. And we know already very well how to go over all the elements in the array. Let's say we go row by row. If you want to go column by column, that's also fine, but it's slightly trickier. So I would say row by row is the easiest one and the most straightforward one to really go over the array elements. Okay, so what I would do is I'm simply just going to say, let's say double the sum. So once I say it's double, so later on when I do division, it's guaranteed to give you a result with precision. That's something we spoke about in the elementary programming lecture, right? Just remember. Okay, let's say sum initially simply 0, and it's going to be coerced into 0.0 into sum. Remember coercion, right? We don't really need to do casting anymore. So as long as it's already coerced into double. And then eventually, we are going to say return the sum divided by how many elements we have in the array, right? That's something we can do. So since we don't really assume how many elements there are, you can see here we don't really say the elements could be the shape of the two-dimensional array could be rectangular. In which case you might just do the number of rows multiplied by the number of columns, but that would be too restrictive because in this case you cannot really calculate the number of elements using that formula that easily, can you? In that case, we better just use another integer counter to count how many elements are there in the array. So we can also accommodate this specific shape, right? And there might be many other shapes that we can also allow for this general algorithm. Let's now go back there. So I would suggest we also get another integer counter over here. That's an integer, let me just say count over here. It's going to count how many elements are there in the two-dimensional array input. So we can say sum divided by count over here, right? So that's going to be calculating the average. So what I will do now is to go over the two-dimensional array using the nested loop. So we can say for integer r is assigned to 0, initialized to be 0, and then r strictly less than. So now you should be very familiar with what this should be, right? So it should be the number of rows, which would be a.length, and then r plus plus. And then we in the loop we're gonna go column by column for each row. So we're gonna say for integer c standing for column initialized to be 0, c less than a at here a index at position what? R over here, right? And then dot length. So this will make sure we can also handle this shape very well. So when we, for example, when we go to this particular row, so that'll be a at index 1. And then when we say dot length, it's going to make sure it's only going to go over this many iterations corresponding to how many elements there are in this particular array in the second dimension. And we'll do that accordingly for every array in the second dimension. So that's why this expression here is so important. Okay. Of course, you don't want to memorize it. You want to see the rationale behind why we are using this expression. And then we're going to say C++. All right, and then for every element, we're going to do two things. Number one, we want to accumulate the sum. We can say sum plus equal array, input array A, and then row in the first dimension and call it in the second dimension, right? That's very standard. And also, we want to say count plus plus. We want to accumulate, also increments the counter for how many elements there are. We are calculating for the average. All right, so that one should work, I think. Let me just go back to JUnit Tests over here, and then let's run it. Okay, it's not really, should be public. So maybe something very silly that I made over here. Public static double get average, and then maybe over here, I think that's my bad. Okay, so here the test should be public. Okay, for some reason I made a mistake over here. The test method you declare for JUnit testing must be public. Okay, let me try it again. All right, everything good, right? Not only the current test, but also all the other tests in the previous problem, they all passed, right? I didn't compromise anything. All right, so that's about the first problem. Let's see how we can solve the second one. The second one is going to do individual row average. So it's going to be very similar to this, the solution for individual row averages. It's going to be very similar to how we calculate the average for the overall array over here. So conceptually, what's going to happen is for every row we are looking at, we should have some local sum and also some local counter. In this case, we may not need a counter anymore because we know exactly how many elements there are in this particular array in the second dimension, right? The idea would be we want to play with the scope of the variable, especially the sum, right? So that's really the insight into this particular problem. That's why I want to discuss them together, right? So you can see the discrepancy between the two solutions and appreciate just by modifying the scope of the variables, you can solve different problems. Okay, let's now see how we can do it. Let me, before I code up the solution, as usual, I want to write up the test case. So I will simply just copy this test over here, and then let me just paste it over here. So it should be public void. Again, your test case must be public. So that'll be test number 4 over here, right? So the same input over here, but now the output is going to come from another method, right? So get row averages. Get row averages on input 1, and the output, the return type is going to be double array rather than just a single double, right? And then what about expected? Expected would be, let me just look at, so it's going to be basically the array of how many rows do we have? We got 1, 2, 3. We got 3 rows. So we want to have 2.5, 6.5, and 10.5, right? So that'll be the expected value. So I'm going to put it here. So it's going to be, let me see, 2.5, 6.5, and 10.5. So that'll be the expected value. And then we're going to compare them. Let's say we simply want to compare them one by one. So that'll be more explicit to see the checks. So what we can do is we can say assert equals, we can say expected at position 0. Let me do the following to see if it might make sense to you. Basically, we want to see output number 1 is going to return an array. So what we can do is this. First of all, we want to say assert true. We want to say output 1.length equals expected 1.length, right? So the length of the output must be the same as the expected output array length, first of all. And then we can write a simple loop over here. It might be a little bit overkill for this particular array, input array of size only 3. We can explicitly write it out, but you can feel free to actually extend the input size. So this loop will be very handy. So I can say for integer I, initialized to be 0, I less than expected 1.length and plus plus. Also, it shows some more creative, manipulation of the loops in the context of a JUnit test. You can feel free to use that in your own test cases. Okay, so I'm gonna say assert equals over here. So expected at position I, and also output 1 at position I with tolerances 0.01. Okay, let's say expected 1, of course. All right. Hopefully, so far you're okay. And let's now do something very similar. So let me just copy this part over here, okay? And then I'm gonna paste it over here. So now rather than output 1, I'm gonna say output 2, and that one, of course, will invoke on input 2, and also expected 2. And what should be the value over here? Let's now review. It's gonna be 2.5. 2.5, 6.6, and 6.0. Okay, let's move back here. So it's going to be 2.5, 6.6, and 6.0. And then we want to make sure output 2 and also expected 2. And this one should be expected 2 and expected 2 and also output 2. Hopefully I made no typo over here, right? So that's how you write the test case, right? So I would say try to really, let me just fix that and I will make my remark quickly. So for many occasions when you write your JUnit test cases, right, you really want to think about if the range of inputs I really need to check is actually quite large. Rather than explicitly writing out the individual assertions, you may just want to consider patternize the assertions using a for loop, which is what I'm doing here. Imagine that if the expected array is actually of size maybe 10. In that case, you can still use just a single loop over here to patternize the 10 checks. So you will only just delegate the actual checks to the individual iterations of the loop. So that's something I want to show to you. All right, let's now go back to utilities. Let's now program that. And the solution will be very similar to the first problem over here, except that I said the inside will be we want to make some local sums and local counts, basically, right? Let me just copy this, and then let me just paste it over here, just for now, okay? Of course, it wouldn't compile because it was only a single double value, but we want to return an array of double. So why don't we create the array over here, first of all? So it's going to be an array of double. So we can say double array, let's say result is assigned to new double array, and what should be the size of this particular double array? Well, it depends on how many rows you have in the input array. In this case, it will be 1, 2, 3. In this case, it will also be 1, 2, 3. Really depends on what's a.length over here, right? Depending on how many elements there are in the array in the first dimension. Let's now just do that. So we can say a.length over here. And then eventually we just want to return the result eventually. Okay, and now we don't really want to. It would be okay if you simply say every time when I start a new row, you can see this is the place, right? Start of a new row. So this is the place. And so this part over here, in the inner loop, this will be the start of a new column. So there will be several ways you can do this. Let me just do this way. Let me say I still want to keep the sum and count as a variable outside the scope for the loop. However, I need to make sure every time before I start to calculate, every time I start calculating for a particular new row. For example, let's say this. After I have calculated the average for this particular row, the sum and also the count would have been set to something that's non-zero already by accumulating these 4 elements. So now when I calculate the row average for the second row in the second dimension, in that case I need to reset both the sum and also the count. Agree? So that I wouldn't accumulate 5 on top of all the other elements from the previous iteration for the previous row. That's really important to understand for this second problem here. So what I can do is I can simply say sum is reset to be 0 over here, and the count is also reset to be 0. You might be wondering, for the very first iteration, for the very first row, we actually the sum and count have just been initialized to be 0. but we are initializing them to 0 again. But I would say that's some imperfection, but it's not going to cause anything it's not going to compromise either the efficiency or the correctness of our code. I think that's okay, right? So that'll be one way to solve it. And then we're simply just going to say sum and also count, right? So we just accumulate in the same way. But now we are going to, at the end of after we have calculated all the columns for this particular row, right? You can think about this part here is the end of the current row. So right around the end of it, we are going to calculate the average. So what we can do is we can say over here, we can say here for the row is going to be 0, 1, 2, right? The row number is going to be 0 and also 1 and 2. So these indices also suggest about the result array. You can see the result array has been initialized to be of size 3, right? So now once we calculate for row number 0, we can store the result into index 0 of the result array. Once we have calculated the average for row 1, we can also store the result accordingly into index 1 of this result array accordingly, right? So that's something you can also visualize yourself. So what I can do is I can simply say result at position R, right? The average for row at index R. And then it's assigned to, and now we can calculate the average pretty much like what we did before. We can say sum divided by count over here. All right. You can see it's not really too many differences between the two solutions, but there are really some critical differences you want to really pay attention to and understand why such differences can really solve two very different problems. Another way to do it, let me just make sure this works, and now I will suggest a very minor alternative for you to try if you want to. Let me now go back to the JUnit test, and let's now run to see this particular get row averages method will actually work. And I just spotted a minor mistake I made. It's more like a typo. Okay, one thing to note. Okay, if you compare the input array over here, you can see this one here is arranged slightly differently over here. Right, it's a minor. I'm not sure if you noticed that. If you noticed that, you will be aware of my typo already. Okay, so it's really 587 as opposed to the previous one 567, right? It's different, right? I should have just copy and paste it without checking carefully. Okay, anyway, so it should be 587. However, when you calculate the entire average over here, it would be the right result. That's why we didn't catch this mistake from get the entire average for the array. But now we should really fix it, because I really want the row averages to be based on 587 rather than 567, right? Let me just go back to JUnit test. I just spotted that. Right? Let's now fix it. First of all, let's see get average over here. So now rather than 567, it should be 587. Basically, swap the order of 8 and also 6 over here. But it wouldn't make a difference for calculating the overall average for the array. On the other hand, it would make a huge difference. Here, rather than 567, it's going to be 587. And this will be 6. So it will definitely change the result for the row averages. So we want the correct result. That would be corresponding to what's really shown on the paper for specification. All right, so let's now try to run the JUnit test. And okay, let's launch the test. And we got a red bar. Let's see why. You can see here assertion error over here. If you double click on the failure trace, it's really referring to this particular assertion, right? And then let's see what else it can tell us. Let me just double click on the tab. And then if I see here, expecting 6.6 is really about this particular slot of the array, about calculating this particular row, 587. Expecting 6.6, but the actual result was 6.6666, etc., right? So you can see it's really a result. It's not really a logical error, but I can tell you how to fix it. It's really about when we calculate sum divided by count, we didn't really specify how many digits it should be after the decimal point. We could have actually made this rather than double, we can try to make a string, so which will be the formatted version of the number. But you can try that version if you wish. It can be an exercise for you. But now what we can do is, when we compare these two numbers, I would say there's really right or wrong over here. It's just about how much tolerance we can actually allow. if you look at these, it's actually the difference will be more than 0.01. You can see if you do the subtraction. So what we can do is we can increase the tolerance level maybe slightly. So that's something you can also adjust. It's not really compromising the correctness, just about adjusting the expectation slightly when you do precision in the division. Let's go back here. So what I can do is maybe for this one only, I can say 0.1 will be the tolerance over here. And let's run it again. And we got a green bar. All right, so it's not working. All right, so that's about solving this particular second problem over here. You can either calculate the overall average or try to calculate row averages for each row, and then returning an array accordingly, corresponding to the number of rows for your particular array. In this case, it just happened that both inputs we are checking got 3 rows, but in general, given any arbitrary input, their row numbers might be different. And then the most important thing for you to really review when you later on check this example is to really see how we actually move, just by resetting the sum and count over here, and also to set the array, the average. At the end of each row is going to give you the different result for this problem over here. So that's the main detail to really review. And another different alternative you can try is to say, rather than declaring the sum and the count over here with their scope outside the for loop, the outer loop, you can actually move. I can just show you quickly. You can actually simply cut this and simply put it over here. So this will actually be okay, since the sum and the count, they are not really necessary. They are really not needed outside the for loop over here, right? So that's actually okay. And if you try it, for example, run it, you will still get a green bar. So this solution will also work. But I'll just actually maybe let me comment this out over here. This will also work, but I will just put it here as the original solution. Okay, so this will be alternative solution. Okay, you can also experiment with that. It's just about playing with the scope of the variables. However, don't forget, we actually have to reset the sum and the count, right? So don't forget. So I'm going to say sum is reassigned to 0, and also count is also reset to 0. It's really important. Otherwise, I'm going to fail the test. All right, just make sure everything will still work. I run the test. Okay, we get a green bar. All right, so now that will be about problem number 2. Let's now move on to problem number 3.